Hey y'all, we're going to start up on our next lesson here, and for this you're going to need actually two sets of notes. It's in two parts, advantages and disadvantages of digital analog, parts 1 and 2. Once again, if you do not have those on paper, didn't get those for spring break, there should be a link up above with those two notes so you can download them, and of course you'll also need a writing utensil. So we're going to be looking at digital and analog, but we're going to be looking at advantages and disadvantages of each. When do we want to use digital things, but when do we want to use analog things? And what are the things we have to consider when trying to decide that? So first thing is dealing with something we call sampling. Analog technology, remember, analog things try to make an exact copy of the original information in a new medium. They copy the whole wave. They copy all the information that's involved. This gives a little bit of an advantage to analog. Digital technology, on the other hand, only converts certain points of the original information. We call them samples into numbers. Remember, with images, we have pixels. It doesn't find the color of everything in the image. It just takes the information at certain points, certain samples, and converts those into numbers. This means there's always some original information lost anytime you ever have a digital signal. We can see this a little bit on like YouTube. You have a choice of what resolution to play your image at. So if you play it at, say, 1080, that means that it is 1080 pixels across from left to right. And so that's a whole lot better image than if you decide to play it at the lowest one, 144. If you do 144, it looks all pixely and blocky because there are fewer samples. The advantage to that, because there are fewer samples, it's sending fewer numbers, which means it can send it faster. It doesn't take up as much space, but the quality is lower. So analog copies all the information. Digital only takes samples. Next one. So go ahead and fill out the page about advantages and disadvantages of these two. Pause your video if you need to. Next one is noise. So anytime you ever copy information, whether digital or analog, from one form to another, there are always errors that show up. You can't make a perfect copy of anything. Analog tries to make it exact as possible, but there's always some errors that are going to show up, and noise is the term we use for these copying errors. Whenever we make a copy, there's always going to be this noise that's involved. So let's say this is the original signal that you send, a nice clean curve here, but because there's always errors that show up, the receiver actually might receive something that looks a little bit like this. They can still tell it's the same picture, but it's messed up a little bit. You know, it's not clean like it was before. And so this extra stuff that's added to it is what we call noise. So noise always lowers the quality of the original information. So in an analog signal, we try to copy all the information exactly here, but we can't do it 100%. There's always going to be some noise here. And what happens if you make a copy of the copy? Well, if I were to take this copy and try to make another copy of it, I would add even more noise on top of that copy. And if I added even more noise, it gets worse. And if I made a copy of that copy, it'd get even worse. And so anytime you try to make copies, you always copy the noise. It's a little bit like taking a photocopy of something and then making a photocopy of that copy and a photocopy of that photocopy. Over time, it gets worse and worse and worse and worse. And this always happens with analog signals. So let's look at an example of what happens if you take an analog copy and make an analog copy of an analog copy of an analog copy. So we're going to take a look at Talking Carl here. He's going to speak something, a second phone's going to record it, and then he's going to play it back and forth, and we're going to see what happens to the quality.
This is Talking Carl.
This is Talking Carl.
He repeats everything you say.
He repeats everything you say.
And he's going to get in a fight.
And he's gonna get in a fight.
My voice is higher than your voice.
My voice is higher than your voice.
So as you can see, the quality gets worse and worse and worse until eventually it's completely incomprehensible. It's just static because that's what happens when you make analog copies of analog copies. The noise adds on and adds on and adds on until it's basically not something you can understand anymore. Digital signals have the same sort of problem, but they have a way to fix it. Digital signals do have noise. The quality does get worse, but when digital signals are received, they're always converted back into numbers, and numbers don't have noise. If you had 1 and Juan, you can still tell that it's 1. Just the fact my voice is messed up a little bit doesn't change the fact that it's still very obviously a 1. So to give you an illustration of this, let's say that we send these numbers digitally, 0, 1, 0, 1, 1. In reality, this is what they're stored as. They are ones and zeros. And that gets sent out as this type of signal. You can see that where it's a 0, it's low. Where it's a 1, the signal is high. And so if we send out this signal, you can tell that's a 0 or that's a 1 just by looking at whether it's high or low. But when we send it, we're going to add noise, some just random messed upness that's going to go on top of this signal. If we add this and this up, you would get something that looks a little bit like this. But notice that even though this is noisy, this is sort of messed up, I can still tell it's a 0. And even though this is very messed up, I can still tell that it's a 1. And so if I received this signal, I would say, oh, well, that's a 0 and that's a 1. And we notice that it's exactly the same as what it was before. Even though there's noise here, I can still tell it's a 1. And so what I receive is a perfect copy of what I had originally. But not if the noise is too much. Here, there's a very large amount of noise. Here, there's a very large amount of noise. And look at what happens. If I look at this signal right here, this looks like a 1. But originally it was a 0. What happened was the noise messed it up so much that it wasn't just slightly off, it was 100% completely off. And the same thing happened here. Even though this was originally a 1, the noise was so far off, it looks like it's a 0 afterwards. And so I received something that was completely incorrect. And this is the problem with digital signals and noise. They're either perfect or they're completely wrong. And so a good example, this is with video. If you look at a digital video, you sometimes get this like in a thunderstorm or sometimes whenever you get like just a bad digital video signal, is most of this picture is perfect. Her hair is exactly right here. This eye is exactly right. Most of the background is flawless. It's perfectly clear. But the parts that are wrong are not just a little bit wrong. They're completely wrong. She definitely does not have skin down here in her hair. There's definitely not a white blob of something that's sitting up that's in here. And so with digital, if there's a little bit of noise, it completely eliminates that noise. We don't have any left over. But if there's a lot of noise, what it gets wrong is not just a little bit wrong. It's 100% completely wrong. It's completely messed up. Analog, on the other hand, everything's messed up a little bit, but nothing's messed up completely. You can still see this fellow. This is a person. He's talking. Even though everything is messed up by some degree, there's no part that's like 100% completely wrong, where it's just a little bit messed up everywhere around the mouth or around the ear or around the hair. And so this is classic for what you see with analog noise versus digital noise. So we'd summarize, if there's only a small amount of noise, digital signals lose no information. Digital signals are far superior to analog. But if there's a large amount of noise, digital signals can be completely lost, where we get no useful information out of it whatsoever, versus analog where you might get some. So go ahead and summarize that on your notes as is shown on the screen. Pause it if you need to. Another advantage digital has over analog is that digital information can be compressed, another word for being shrunk, so it takes up less space. But analog, it's really tough to do that. So if you have a signal and you take the information, make it take up less space, it means it's easier to store, it's quicker to transmit. So we can send it faster and we can store more of it. It's the reason why if you wanted to take, for example, 10,000 photographs that were analog, that were on paper, that would take up boxes and boxes and boxes of space. But with digital, you can put that 10,000 photos on your phone really easy, or you could even put them on a little SD card, which is like, the size of your pinky nail, that can store tens of thousands or hundreds of thousands of photos, because we can compress digital photos really easily. It's really hard to compress analog things. So how does compression work? So imagine that we have these numbers. It's digital data. It's stored like this. First thing that stands out here is we got this long string of 8s in the middle, basically where the information repeats itself. And that happens in digital things all the time. So because they repeat, we could just say 8 13 times. Just write it in the digital information. So instead of saying write the 8 13 times, we say, hey, just take that 8 and repeat it 13 more times. I've shrunk this. This set of numbers is much shorter than this set of numbers. And that saves us space. That's how compression works. So if we compress it perfectly, there are no changes, just like that last example. We said 8 13 times, it could uncompress it, and it would write the 8 13 times. We don't lose any information. That's called a lossless compression. No quality lost whatsoever in a lossless compression, but there's only a very small change in the size of the file. So we shrink it, but we don't shrink it by much. For a lot of music streaming services, you can pay extra money and get hi-fi sound. It's lossless sound. Tidal does this. You can do the same thing, I think, with Spotify. And so you get a much higher quality signal, one where there is no information lost to compression, but since it doesn't shrink the size of the file, it means streaming is a lot harder, is that it takes more time to send the information. It might have to buffer for a lot longer, or you just have to have a much better signal, much higher speed data connection to be able to listen to it or to watch it if it was video. So the other way we can deal with this is instead of using a lossless compression, we can use what's called a lossy compression. And so lossy compressions work like this. They look for places where the data is close to being a repeating pattern, but not exactly. So suppose our number sequence is 8887, 888. Oh, that's really close to being all 8s. But 7's really close to 8, so why don't we just change it to an 8? Because that way we could shrink this file down smaller, and is anyone really going to notice the difference between, it being a 7 and being an 8? Maybe not. In terms of like pictures, it could be something like saying, hey, right here there's a pixel that's white, and right next to it there's a pixel with a slightly different shade of white. Well, and that means the numbers are different. But can we really tell the difference between those two shades of white? And if we can't tell the difference, why not just claim they're the same shade of white, so that way we can repeat it and we can shrink the file size down. And that's a lossy compression because the information is lost. You can see the word loss in the middle of lossy. And if we use lossy compression, we can shrink file sizes down by over 90%. So over on the right-hand side, we have an original picture, and we have a lossy compression, like an extreme lossy compression. This one's been done way more than you probably would need to. And as a result, this file is only about 2% the size of this one. You could send 50 of these files or store 50 of these files in the space that it would take to store one of these. So it would send 50 times faster as well. But the quality is horrible here. So instead of just saying, hey, this pixel and this pixel are close enough, this one's saying like this pixel and this pixel are close enough. And I can definitely tell that that pixel is a lot whiter than that pixel. But down here it said, I'm going to call them the same shade of white because that saves a lot of space. That completely messes up what's going on in here, is that you can't even tell any of the detail in the middle of the flower, where here you can sort of tell what the detail is. This is a very lossy compression. So why would you want to do this? Well, as we said, it shrinks the file size down, but at the cost of losing a huge amount of quality. But losing quality doesn't matter in some circumstances. You've got to be present, physically present to steal. It's easier to keep private like we have right here if you have it like locked in a safe only in one spot. Disadvantages to analog in terms of copying. It's hard to back up that information. It's hard to share it when they're this small. Advantages for digital. It is easy to move it. It's easy to share it. It's easy to back it up. But that same fact that it's easy to move it or share it means it's also easily to be stolen and can be hacked. Go ahead and fill out your table on the end of an image or a GIF. A GIF is basically a way of compressing the file. Now, if we have a digital signal, we said digital signals are easier, and digital information is easier to steal. It's easier to hack. We could have anyone in the world could hack into your phone, no matter where they are in theory. But there is a trick that we can use with digital that we can't use with analog for digital and analog when we talk about compression. So digital signals are numbers, and numbers you can put into codes. You can have mathematical formulas that code them, and if you know that mathematical formula, you can decode them. And so that type of coding is called encryption. Digital information can make digital signals very private. It doesn't make it so they're any less easy to steal, but it makes it so that if someone steals them, they can't read the information. So if you had a picture that you didn't want people to steal, or it's a lot financial information, you could encrypt it instead, and then if someone did steal it, they
couldn't make any
if I
sense of
have
it. It would be
a
useless
photograph
to them.
that's on paper, trying to make
Now,
another photograph
analog, on
on
the other
paper.
hand, it's very
Analog
difficult
copies
to
are
encrypt most analog
relatively
signals.
difficult
It can
to
be
copy,
done, but it's
digital,
usually
it's just
very
taking
time
numbers from
intensive.
one place to another.
It's
If
very
I have a
difficult
photo
to do.
on my phone,
and
a
so
digital photo,
normally with analog,
and
if
I
someone
want to
gets
share
a
that
copy,
with
they
someone
can read
else,
that copy.
I just hit
Encryption
share.
doesn't work
The
so well,
computer inside
with
your
digital
phone just makes a
signal,
copy
with
and
analog
sends those
signals.
numbers somewhere else, and you have a very
Another
good copy
problem we
that's
run
right there.
into with analog is that if you're trying to access something that's analog, like a record or like a VHS cassette, a machine has to actually physically touch the medium that the information is stored on. In most cases, to play a record, you have to put a needle into the record groove, and so as that needle goes around in the record groove, playing back the information, the music that's on that record, is that it damages the record. It sort of grinds out that groove. That groove is no longer the same as what it was originally, and so the quality has dropped off. Those of you who did still have VHS tapes when you were kids, remember that if you watched the same VHS tape, analog, over and over and over again, it got worse and worse quality. And that seems to be true for pretty much all types of analog things. Even analog things you wouldn't expect, like looking at photographs. The more times you take that photograph out, you expose it to UV light, the worse quality it gets. Now, on the other hand, digital things, if you look at a digital picture in your phone, it doesn't change the quality of that picture. You listen to digital music on your phone, you watch a YouTube video, it doesn't change the numbers. They're just reading numbers whenever you're looking at the digital information in some sense. And so just reading a number doesn't change the number, and so the quality tends to stay the same whenever you use digital things. So analog, the more times that you view it, the more times you listen to it, the more times you watch it, the less and less the quality is, the worse quality it gets. Digital, the quality stays the same. Now, while it is possible for computers to break down, to have problems, for hard drives to fail, because of the fact digital is easy to copy, it means we can make backups really easily, and then we replaced it with a copy that's exactly the same quality as what it was as an original digital copy. Keeping in mind that the sampling of digital things still means that the quality is not going to be quite as good as it was with analog at the beginning. It's just that digital doesn't degrade, doesn't lose quality over time, whereas analog does. So another thing that we have to run into is dealing with storing type of information. Each type of analog signal typically requires some sort of specialized equipment. If I have a record, I need a record player to be able to listen to it. I can't take a record and stick it into a VCR. I can't take a film off of a projector, a film projector like they used to use back in the old days. That was analog video, and I can't stick that onto a record player or into a VHS, into a VCR. And so if you want to use an audio cassette, you need to have a cassette player. If you wanted to listen to a record, you had to have a record player. But digital signals, you just need a computer. If I want to watch if I want to look at a digital photo, I need a computer because it stores numbers. If I need to listen to digital music, digital audio, I need a computer. It stores numbers. If I want to do digital video, I need a computer. It stores numbers. One piece of equipment for all types of digital signals. Even things that are digital that haven't been created yet. So maybe someday they'll come up with digital like holograms that can move around. If they're digital, they can still store on a computer. Even though it's a technology we haven't invented yet, because it's digital, we know they can be stored. We know they can be sent on computers, even if they have to be more powerful computers than what we have today. Now, the disadvantage of that is that computers tend to be more expensive and tend to be more complex than analog technology. Analog technology like record players, VCRs, even looking at photographs, books, are much simpler, much cheaper, and much easier to build. Computers require vast sets of technology to be able to build. You would never be able to build a laptop from scratch. You'd have to be able to buy the parts to be able to put it together from a factory that put those together. But on the other hand, if you needed to make a record player from scratch, you really could do it if you had enough time. Certainly you could make a book if you needed to, or even to develop photographs. It doesn't take as high of a level of technology. So go ahead and fill out on your notes basically the advantages and disadvantages of analog and digital with respect to storage. Pause this video as you need to. And then our last one here is number of signals. Is that it turns out we can send many digital signals at the same time, but it's relatively difficult to send multiple analog signals at the same time. The reason why is digital signals are numbers. It really doesn't matter whether we send the numbers for one like video stream or we send the numbers for 5 video streams. Whatever your bandwidth is, as long as you have enough like bandwidth to be able to carry all those numbers, it doesn't matter if you send one signal or many signals. And this is the reason why that back in the day when it was analog, if you ask your parents or ask your grandparents when they were kids and they were talking about watching television, your grandparents might have had like 3 or 4 stations they could watch, only 3 or 4 video streams so they could watch at a time. And then we got to satellite and cable TV where it could be a few hundred. But today on YouTube, there are like 5 billion videos on YouTube. And so you could have 5 billion people watching 5 billion different videos all at the same time. And that's not really necessarily a problem with digital. But analog, it can be much more difficult to send multiple signals all at the same time.